There's lots of ways to convert things in math. You probably already know how to do this. But when it comes to chemistry, we tend to use something called dimensional analysis. So let's start with a simple example. 60 seconds is equal to 1 minute, right? We can agree that 1 minute is defined as 60 seconds. If that's the case, just stay with me here for a minute. I can say that 60 seconds equals 1 minute, as I've drawn down here, and divide each side by 1 minute, right? So I put 1 minute down here, and I put 1 minute down here, and therefore, these two cancel out. That's the same thing as saying it's equal to 1, which means that 60 seconds divided by 1 minute is equal to 1, right? Okay, well, let's convert this the other way. Let's do something different. We can divide each side by 60 seconds. So we put these on the bottom. These two cancel out. And guess what? That equals 1. So that equals 1. Right here, we have this version of that equation, or we can have this version of that equation. We call both 60 seconds over 1 minute and 1 minute over 60 seconds inequalities, and we can use those in mathematical equations in order to get units to where we want them to be. So just as the same way you can multiply anything by the number 1 and not change its intrinsic value, you can use these inequalities in in calculations, and that does not change the value of these things. They're just conversion factors. So you're moving it from one type of unit to another. So for example, let's say we wanted to figure out how many seconds are in 1.25 minutes. Well, we say 1.25 minutes, because I usually want to start with a thing with one type of unit, by the way. And I want to multiply that in a way that cancels out my units of minutes and gives me the units of seconds. Well, in order to do that, whatever's on the top here, because remember, this is all over 1, I want to put on the bottom in my inequality. Because when I do that, looky here, the minutes here and the minutes here cancel out. And now my unit is in seconds. So then what you do to figure out the actual math part is you take 1.25, because again, that's on the top, it's on the numerator. You multiply that times 60, and that gives you the value that you need. And your unit is now seconds because the minutes canceled out. Finally, you need to figure out how many significant figures you have. Well, remember, we have this power over here in this inequality because this is an exact number. So we don't have to worry about the number of significant figures there. And that means whatever we started with is how many significant figures we should answer with as well. Okay, we can do the opposite as well too. Let's say you have 1,200 seconds. Well, if I want to know how many minutes that is, I just use the opposite inequality. I put the seconds on the bottom and put minutes up top. And what that does is the seconds will cancel out and you'll be left with the unit of minute. So in this case, again, this is an exact number. So we don't have to worry about, the significant figures here. But we only have 2 significant figures on the left. So that means that we need to give just 2 significant figures. Now, right now, you can't really tell that that 0 is significant. So the best way to solve that is either add a decimal point, or we could say it's 2.0 times 10 minutes. Why didn't I put 10 to the 1? You could have done that. Just 10 is also the same thing, so we don't have to worry about that. So when it comes to approaching dimensional analysis problems, there are certain things that I would suggest that we start with. First of all, you want to identify what it is that you have with known values of units. It's usually easiest to start with something with a single unit instead of like minutes per second or something like that, like density. It has multiple units to it. So then identify what your unknown units are. In other words, what do you want to give in your answer? And then this is vital. You have to find conversion factors that contain the knowns and unknowns. And sometimes you have to do it in a way that you can sort of link two things together that you aren't even part of the knowns or unknowns. And then you've got to multiply conversion factors so the denominator or the bottom units cancel out with what is previously in the numerator or the top units. So that's sort of what I just showed you. Continue with this process until you have the unknowns. And then the very important step that you can't miss, you have to calculate this stuff. You got to multiply the numbers on the top or on the numerator and divide by those that are on the denominator. So let's do some more examples. Okay. First, if you have a 6-ounce steak, how many kilograms of steak do you have? Well, you've got to start out with some knowns. And you might ask, well, how do I find these? Well, guess what? Most of these things are out there or will be given to you in a problem. If it's something like converting from grams to megagrams, guess what? You should know that one. But when it comes to pounds and ounces, I would give that to you in my class at least. So here we go with 6 ounces of steak. That's our known. That's what I'm going to start with. And then I'm going to try to find a way to get to kilograms. Well, I have the relationships that I need. And so I can take this 6 ounce, that goes on bottom, or 16 ounce, sorry. And whatever it's equal to, that has to be on the other side, right? So one goes on bottom, one goes on top. How do I know that I want the ounce on bottom and the pound on top? Well, ounce goes there, then it cancels out with that one. Now, one of the things that I've seen people, struggle with sometimes, the 16 goes with the ounces. Those two cannot be separated. You can't say 16 pounds is 1 ounce. Right? That would make no sense. That would not be the right value. So make sure that you do put the 16 on the bottom there with that ounce, okay? So the next thing is, what that means is that we're now in a unit of pounds. Don't worry about the numbers for right now. So in this case, we have 1 pound, and we have an inequality here that 1 kilogram is equal to 2.2 pounds. Well, if my pound is on the top, I now want to put it down here on the bottom. Because if I put it on the bottom, they cancel out. So I get out of pounds, and my unit is now kilograms. Guess what? That's what we want. That's our unknown. That's perfect. So now you get your handy-dandy calculator out and you say 6 times 1 divided by 16. And all of that is divided by 2.2. Now it depends on how you put your things in your calculator. Make sure that you do get 0.17 as your answer here. And if you're having difficulty with that, please let me know. Now keep in mind, this is an exact value. I'm not sure if this is an exact value, but we can assume that it is for right now because this only has 1 sig fig, which means that we need to report this to 1 significant figure. So that's about 0.2 kilograms of steak. Okay, so it is absolutely vital that you practice this a lot. And I mean a whole lot. You're going to, whether you like it or not. if you don't master these now, you're gonna not be happy because they're not going away for a lot of chemistry. And the reality is if you go further up in chemistry, you still have to remember how to do this stuff. These are the types of problems that can really help you in life. There's tons of them on the internet. I very much encourage you to practice them, and I will give you plenty of opportunities to practice that in the course as well. Thank you very much.